Right now, inside every single cell in your body, there is a built-in biological reset system more sophisticated than any supplement, detox, or longevity hack on the market. This is not a metaphor. It is not motivational language. It is a real cellular mechanism so foundational to human survival that it earned a Nobel Prize in physiology or medicine. And yet, despite its power, most people unknowingly suppress it every single day. The issue is not that your body lacks the ability to repair itself. The issue is that it is constantly receiving the wrong signals. Many people try intermittent fasting, low-carb diets, metabolic reset protocols, and extended fasting, yet they still feel tired, foggy, or metabolically older. They assume they need more discipline, longer fasts, fewer calories. But biology does not respond to punishment. It responds to information. And when the signals are misaligned, even the most disciplined fasting routine may fail to activate deep autophagy, mitochondrial renewal, or meaningful metabolic flexibility. Before we talk about how to turn this system on, we need to understand what it actually does and why it matters for long-term metabolic health and longevity. A few years ago, a 44-year-old executive told me something that stayed with me. He had been practicing intermittent fasting for nearly 8 months. He tracked his macros, kept his carbohydrates low, exercised 5 days a week, and even experimented with 2 4-hour fasts. The scale moved. He lost weight. But what unsettled him was something else. He felt colder than usual, more fatigued. His mental clarity came and went. "I thought fasting was supposed to make me feel younger," he said. He assumed he needed to push harder, fast, longer, cut more calories. But he wasn't failing. He was activating the wrong biological switches. His body was burning fat, yes, but fat loss and cellular rejuvenation are not the same process. To understand why his energy felt inconsistent, we have to go deeper inside the cell itself. Autophagy is often described as cellular cleanup, but that phrase barely captures its importance. From a biological standpoint, autophagy is the process by which your cells identify, break down, and recycle damaged or inefficient components so they can maintain long-term performance. It is not self-destruction. It is internal renewal. Every day, normal metabolism generates damaged proteins, misfolded structures, and cellular debris. Oxidative stress, inflammation, and even regular energy production create microscopic wear and tear. If that debris accumulates, signaling becomes inefficient, energy production declines. The cell becomes metabolically sluggish. Autophagy is the difference between a cell that ages functionally and one that preserves adaptability. One of its most critical roles involves mitochondrial quality control. Mitochondria are responsible for producing ATP, the energy currency that powers every heartbeat, thought, and movement. When mitochondria become dysfunctional, they generate less energy and more reactive oxygen species. Autophagy selectively removes these damaged mitochondria, allowing healthier ones to replace them. In simple terms, growth mode and cleanup mode cannot run at the same time. When the body prioritizes constant construction, it pauses repair. And if repair pauses for too long, metabolic efficiency gradually declines. So, if this system is built into us so elegantly, why does it feel so dormant in modern life? If autophagy is built into human biology, the reason it feels inaccessible today has less to do with genetics and more to do with environment. For most of human history, food availability was unpredictable. Periods of mild energy scarcity were normal, even expected. In that setting, cellular repair was not optional, it was adaptive. But modern life is different. Meals are frequent, snacks are constant. Sugary beverages, protein bars, and late-night eating keep insulin elevated for most of the day. Insulin is not a harmful hormone. It is essential, but it is a signal of energy abundance. When insulin is high, the body shifts into growth and storage mode, activating pathways like mTOR that prioritize building over recycling. And growth mode and cleanup mode cannot operate simultaneously. The issue is not that people eat too much, it is that the body rarely experiences a meaningful metabolic pause. Even moderate calorie intake, when spread across the entire day, can keep autophagy shallow. But insulin is only part of the story. There is another signal most people misunderstand completely, and that signal is hunger. In modern culture, hunger is treated like a warning light that must be shut off immediately. We are told never to skip meals, never to feel discomfort, never to let appetite rise for too long. But from a physiological perspective, short-term hunger is not an emergency. It is a signal. When a hunger pang appears, it is largely driven by the hormone ghrelin. Ghrelin does more than increase appetite. It tells the body that external energy may not be immediately available. In response, cells begin shifting toward internal efficiency, conserving resources, and initiating deeper repair. A typical hunger pang lasts about 15 to 20 minutes. If it is not interrupted by food, it often fades on its own. That fading is not willpower. It is physiology. When ghrelin rises and insulin remains low, autophagy begins to move from shallow initiation into active engagement. If food is consumed immediately, the signal is cut short, insulin rises, growth pathways activate, cleanup pauses. This is why some people fast for years, lose weight, yet never feel metabolically lighter or clearer. Fat loss can occur while cellular repair remains minimal. Once hunger is understood as a temporary biological window rather than a threat, the strategy becomes more precise and far more sustainable. Once hunger is no longer viewed as an emergency but as a biological activation window, the question becomes more strategic. How do we amplify that signal without pushing the body into extreme deprivation? The answer is not longer fasting alone. It is signal stacking. Instead of relying on one pathway, we layer multiple physiological cues that all communicate the same message: temporary energy scarcity and cellular adaptation. The process begins the day before fasting. Lowering carbohydrate intake to under 50 grams and moderating protein helps reduce baseline insulin and deplete liver glycogen, shortening the time required to reach deeper autophagy. When the fast begins and hunger appears, allowing that 15 to 20-minute ghrelin rise without immediately eating strengthens the internal shift toward repair. Light movement during this window, walking, stretching, or gentle mobility work, activates autophagy through independent metabolic pathways and increases fat mobilization. Heat exposure, such as a sauna session, stimulates heat shock proteins that support cellular repair and mitochondrial health. Non-caloric electrolytes can improve comfort without interrupting the signaling process. Compounds like green tea, black coffee, and polyphenol-rich foods may further support autophagy and metabolic flexibility. Finally, breaking the fast strategically, avoiding large carbohydrate spikes and excessive protein, prevents insulin and mTOR from abruptly shutting down cleanup mode. When multiple signals align, the body does not struggle. It adapts. And yet, even after activating these pathways correctly, a few subtle mistakes can shut the entire process down within minutes. Even when fasting is executed correctly, a few subtle inputs can reverse the entire biological shift in minutes. One of the most common misconceptions in the fasting and longevity space involves amino acids. Branched-chain amino acids, essential amino acids, collagen peptides, and even bone broth are often labeled fasting safe. They may contain few calories, but biologically, they are loud signals. Amino acids, particularly leucine, activate mTOR, the pathway responsible for growth and construction. And when mTOR turns on, autophagy turns off. At the cellular level, amino acids are not neutral. They are a command to stop cleanup and start building. The same applies to a high-carbohydrate meal immediately after breaking a fast. Insulin rises sharply, signaling energy abundance across tissues. Repair pauses. Storage resumes. Even frequent protein intake spread throughout the day can keep mTOR chronically active, reducing opportunities for meaningful cellular recycling. The solution is not fear of protein or carbohydrates, but strategic timing. When biological signals are clear and consistent, the body adapts efficiently. When they are mixed, the repair process becomes shallow and incomplete. When autophagy is activated correctly and sustained long enough, The results rarely appear dramatic at first. They unfold in a sequence. Within roughly 10 to 14 hours of low insulin and stable signaling, many people notice something subtle but consistent, clearer thinking. Neural cells function more efficiently when cellular debris is reduced and low-grade inflammation decreases. Focus feels steadier. Mental energy feels smoother rather than stimulated. Between 14 and 18 hours, as metabolic flexibility improves, energy regulation begins to stabilize. Blood sugar swings become less intense. Urgent hunger signals decrease. Feeling not hungry yet not fatigued is often a sign that the body has shifted toward internal fuel use. After breaking a fast strategically, many describe a sensation of feeling lighter or clean, not from dehydration, but from reduced bloating and inflammatory heaviness. Over several weeks of consistent practice, insulin sensitivity often improves, mitochondrial efficiency strengthens, and reliance on constant feeding diminishes. These changes are not extreme, they are adaptive, and that subtle progression is precisely why they tend to last. When we step back and look at the full picture, the most important insight is not any single fasting trick, supplement, or protocol. It is the logic that connects them. Autophagy is not a reward for extreme discipline, nor is it reserved for those who fast the longest. It is a built-in survival mechanism shaped by evolutionary biology, designed to activate when the environment signals temporary energy scarcity. Your body is not resisting you. It is responding to the information it receives. When insulin remains low long enough, when hunger is allowed to complete its natural hormonal rise, when movement and heat reinforce the signal, the shift toward repair happens without force. This is not about starving. It is about restoring metabolic rhythm. It is about metabolic flexibility, mitochondrial health, and long-term longevity, not quick weight loss. The goal is not to fight hunger, but to understand it, not to override biology, but to work with it. Your body is not broken. It is waiting for the right signals,